Right, part B. This is showing us a table tennis ball. Its experience of drag as it travels through the air. Figure 16.1 shows the ball in three different situations: A, B, and C. The ball has a weight W, and the drag force is D. So the first part, B part I. Draw an arrow to show the direction of travel on the ball, of the ball in situation A. So the direction of travel is going to be opposite to the drag force, because the drag force is always going to be opposing its motion. So here we go. I would come in and I would draw an arrow going off in that direction there. A very common mistake, what people did is they did some kind of a resultant force between W and V, but what we're looking here is the direction of travel, so this is going to be our arrow here is going to be the velocity vector, essentially, whereas D and W are both forces. Part 2, in situation B, the magnitude of the weight and the drag force are the same. Explain whether or not the ball is travelling at its terminal velocity. Right, well, for starters, explain whether or not it is or it isn't. Well, if we're in situation B, okay, so these two forces are of equal magnitude, but they're not in the opposite direction. So if I was to add those two forces together, let's just make a little sketch of that up here. So I would have D, and then I would have W, drawing them out tip to tail. Therefore, my resultant force would be that. So if there's a resultant force acting on the object, it cannot be travelling at its terminal velocity. So let's just put that in. Not travelling at terminal velocity. And always a good idea in an explain question is to use the word because. What am I doing with my pen? There is a resultant force. Acting. Okay.